Welcome to the video demonstration of our EEE 310 communication project. We are grateful to our course instructors Ms. Mahnaz Islam and Ms. Sumaya Wahid for giving us the opportunity to work on such a project. Our project includes image processing and microprocessor based hardware operations. Now let's move on to the operation of our project. We have used an Android app named IP Webcam. What IP Webcam does is it transmits any media file from Android to Matlab using the IP address of the Wi-Fi it is being connected, and in our case it has used the URL of the video that we want to transmit to Matlab. After transmitting the video, the next step is to connect our PC to the Arduino Uno board using Bluetooth connectivity. In our case, we have used a Bluetooth module HC06. Bluetooth module basically carries a character from Matlab to Arduino based on the results of image processing. Now we move towards the main image processing portion of our code. Firstly, we extract image frames from video using the snapshot function and then do image processing on different frames. Initially, we convert the frame into grayscale using the RGB to gray function and then keep only the color component that we want to track by subtracting all the other color components using the IAmSubtract function. Then after filtering the frame, we convert the frame into binary scale. And then after applying different image processing functions, finally we apply the region profs function on the binary scale image to get all the necessary information about the object. For a successful tracking, the most important properties of the object that we need to extract are the centroid of the object and the area of the object. Now, if the area of the object becomes larger than the previous frame, this means that the object is moving forward, and so the robot must move backwards. On the other hand, if the area of the object in the current frame becomes smaller than the previous frame, this means that the object is moving further and the robot must move forward to track the object. Similarly, if the area of the object remains same as the previous frame, this means that the object has not changed its position and the robot must also maintain its position. In that case, the Matlab command window will show a center. Finally, to move towards other direction, we have set a threshold, which is here, x1 minus 90 and x1 plus 90 towards x-axis. If the coordinate of the centroid of the object becomes larger than the threshold, then this means that the object has moved towards right and the robot must also move towards right. If the coordinate of the centroid of the object becomes smaller than this threshold value, then this means that the object has moved towards left and the robot must also move towards left. Finally, the results of image processing is sent to the Arduino Uno board using the Bluetooth connectivity. We send the first character of the corresponding movement to the Arduino Uno board. For example, for right movement, we send the character R. For a backward movement, we send the character B. The Arduino board operates on the motor driver accordingly. Since we used a dual DC motor driver, we defined 4 constant integers for 4 pins of the 2 DC motors, and the other 3 constant integers H, L, and M denote different speeds of the motor. Now when the Arduino receives a character L from Matlab, which denotes the left movement, the right motor rotates at a higher speed than the left motor. Similarly, when the Arduino receives a character R, the right motor moves or rotates at a lower speed than the left motor. For center movement, all the motor's pins are disabled. And for a forward movement, both the right motor and the left motor rotate clockwise at the same speed. And for a backward movement, both the motors rotate anti-clockwise at the same speed.